So let's start with the problem and the diagram, all right? We need to be able to break it down. So they're going to give you different diagrams, and some of them look crazy, all right? So the first thing that I do, all right, eyes on me, phones up, phones away, phones away, phones away, all right? The first thing I do is I say, okay, they're talking about triangle EHG, all right? So EHG, right? E, H, and G. The first thing that I do is I'm going to outline that triangle. So I outline it, all right? And now I know what triangle we're talking about. Now, they've given us some things, right? We know this angle's 30 degrees. We know this angle's 30 degrees, 60 and 60. What else have they given us? Somebody said something back there?
You said it's 30, 30, 60, and there's a right angle.
A right angle at the top, right? So that tells us that the combination of those two angles, right, are 90 degrees, correct? So on the left side, it's 30. Karen, what do you think the right side is? What's that? Well, if that's 30 and this angle here is 90, right? So if I've got an angle, right, and we know that's 90, okay, and this is 30 here, what do you think that is? The total, right, the total of the angles is 90 degrees. If that's 30, what's that? 60, right? So, look, we can just say 60 degrees there. Okay, so that's for the portion that is to the right of the line. To the left of the line is 30. Okay, so Jordine said we had a right angle there, right? We were able to figure out that that angle right there, which is FHG, is 60 degrees. So I got one more angle I need the measurement for, right? So it's this one right here. What do you think, Alyssa? Hey, we don't need computers right now. We don't need phones. Come on. Jordan? What do you think the measurement of this angle is? What's that? All right, let me ask you this. What is the measurement of a straight line? 180. And what did they tell us here? Okay, so if the measurement of a straight line is 180, and this is 60, what do you think this angle is? Thank you, Zane. Yeah. Nice! Exactly, 120. So, now we have an idea of all the angles, okay? Based on what they gave us, we were able to figure out, okay, good. So now we know all the angles, all right? So I got 120 there. So EHG, I outlined it in blue. EHG. What type of triangle is this? Jordine says isosceles. Who agrees with her?
What triangle? EHG.
Yeah, the blue one.
Wait. The line is leaning.
What's that?
The line's leaning.
Well, the line's leaning?
That line.
Okay. Alejandro. Yeah. Triangle EHG. What do you think that is? What's that? Well, angle H. What's the measurement of angle H? What? Who said that? Julie? Did you say it's 90? If there's a right angle in a triangle, what is it?
Oh.
A right triangle. Right? Okay. So now So that triangle's right. Now here's my next question for you. If we were to classify it by sides, how would we classify that? Would that be, let's see, oh,
Sides are like
equilateral, right?
per side.
Yeah, equilateral. Scalene,
That's also
or isosceles. Isosceles. So, would this triangle be equilateral? Julie says no. We're still talking about this one that I did in blue. Here, what color you want me to do it in? Let's do it in red. All right. Okay, so I've outlined that triangle. It's in red, right? So we know it's a right triangle based on its angles. But now we're trying to figure out based on its sides. So, Julie, what did you say again? What's that? You said no to an equilateral, right? Because the sides are not all the same.
Yeah.
And we don't have 60 degrees. Each angle, right, would be 60 degrees. That would be equiangular, equilateral, they're the same thing. Okay? Now, using that same logic, all right? We've got a 90-degree angle here, okay? Oh, what's isosceles? No. Scalene is if it's leaning, right? So,
You said, oh yeah, you did. Okay.
so look. Isosceles has two congruent sides. Iso, all right? Iso means equal. This root, it's a Latin root, okay? Iso. In chemistry, okay, or pharmacy, you taking pharmacology in college right now, Cindy? Nutrition. So have you ever heard of isotopes? Okay, so that's chemistry. It's really physics. Nuclear fission is based on isotopes, meaning they're the same. Okay, so isosceles, that root means the same. So we've got two of the same sides. Equilateral means we've got three of the same sides. All right, and then we've got scalene. Scalene, typically, if it's leaning, okay, and this one is kind of leaning, right? None of the sides are the same. You may use the restroom. So we've got a scalene triangle in this case. And I also know that because if we have an isosceles triangle, okay, or let's use the equilateral, the opposite sides, okay, opposite sides at opposite angles. If the angles are congruent, then the opposite sides are congruent. All right. So in this case, we have a scalene, a right triangle that is scalene. All right. So let's talk about methodology on the next triangle. So who can come up? Who can come up and outline this next triangle? You want to try it? You can outline. Look, see. Yeah. All right. So let me ask you this. What's the measurement of that angle right there? Well, no, you just remembered that we said it was 120. But how did we come up with that?
straight line, 180.
180, 60, 180 minus 60 is 120. Go ahead and write it in, just so you got it. Now, remember that opposite angle theorem that I gave you, right? So, if this angle is 30, and this angle is 30, right? This angle's 30, and this angle's 30. What does that tell us about the opposite sides on that triangle? What's that? Not there.
That side?
So, remember, we're going here, right?
Mm-hmm.
And we're going here. The opposite sides and the opposite angles are congruent. So we know that these angles are congruent, so the sides are therefore congruent.
Okay.
All right? So we know that these two sides are congruent because the angles are 30, right? Because the angles are congruent. So what do you think? Do you think this side here is going to be congruent? Oh, Danielle, your hair. Look at you. You want to come on in? Come on in and enjoy a little in class. You can sit right there, or actually you can sit by Jordine. She'll help you out.
Sure.
Huh? So, do you think that this side is congruent to these two sides? Look at it. Is it the same length?
No.
No, it can't be. Right? Okay. It's not, because we got a 120-degree angle. Right? So, what type of triangle do we have here? Based on angles. So my angle options, right?
Oh, it's equal. No, it's isosceles.
Isosceles.
It's two equal.
So that's based on the sides, right? So my classifications for angles, right? I've got obtuse, I've got acute, not cute like Danielle cute, but acute, right? And then I've got right, and what else do I have? Obtuse, acute, right? What else do I have? Oh, equiangle. There you go.
And that's one angle equal. That 3 or 2 equal.
All the angles, equal angles, okay? Equal angles, equal sides. And Mackenzie, was that you who just sent a chat in?
Was I what?
Oh, I was just seeing if it was you that sent the chat in.
Oh no.
Go ahead. So this triangle that we're dealing with right now, how would you classify that as far as angles go? It's not right because it doesn't have a 90-degree angle, right?
It's not equal. Our angles are not equal.
Okay. So you got two choices, obtuse or acute. Acute like a baby turtle cute, girls don't kiss baby turtles, or obtuse. Obtuse. We have one angle that is greater than 90, right? So it's obtuse. Okay. So we've got an obtuse triangle, and we've got two angles that are 30 degrees, so the opposite sides of those are also congruent.
So is it 2 to 1?
Obtuse, and well, you tell me. If we've got two sides, right, my options are equilateral, scalene, where none of the sides add up, or isosceles, where we've got, yeah, you got it, isosceles.
I don't know how to spell that though.
Don't worry about it. I don't know how to spell it either. I make it up every time. It's kind of like when you know, I put like 9 plus 4 on the board, and I tell you it's 12, and you guys agree.
We're not getting this.
All right, so, oh, hold on a second.
Is that right?
No, you got it.
Okay.
So I got one last question for you. The last FHG. By a show of hands, who can tell Jordine what kind of triangle that is? Danielle? FHG. We got 60 degrees, 60 degrees. What do you think the measurement of that degree, of that angle is? It's got to be 60, right? How do you know that? Huh? 180 divided by 3. All the angles add up to 180, divide by 3, right? So it's 60, okay? So what type of triangle we have here? These are options. This is for angles, this is for sides. Are all the angles equal? Equiangular, all right, equiangular. And using that same or the same idea, opposite angles, okay, opposite sides, make these congruent. If the angles are congruent, then the sides are congruent. So that tells me that it is equilateral, right? Oh.
One for the two sides.
This is a good question. Eyes on me. Jordine just asked me the relevance of 2 ticks versus 1 tick, or 3 ticks. Explain it to me as you might understand it, darling. So it doesn't matter how many ticks it is. It could be 1, 2, 3, 4, 1,000 ticks. As long as the number of ticks match, they're congruent. Make sense? Yeah, so as long as, so in this case, right, working with this triangle here, right, if I have 2 ticks, 2 ticks, 2 ticks, all those sides are congruent, all right? If I had 4 ticks, 1, 2, 3, 4, 1, 2, 3, 4, what's that? Oh.
They all have to be the same.
This is a great question. Show of hands, who can tell me what type of triangle that is? Done. This and this, these 2 sides are congruent. This is not.
Okay, the two.
Count the number of ticks, that's what matches. Same thing with your angle marks, right? So if I told you that we had, let's call it 1, 2, 3, 1, 2, 3, and 1, 2. What type of triangle we have? Don't look at the numbers. What's that? 2 equal angles. 1 that's not. 1, 2, 3, and 1, 2, 3, because I'm going to the opposite side, right?
Yeah.
Okay, isosceles. So that's the significance of the ticks. And it's really, I'm going to show you guys a problem, probably after lunch, and you're going to be like, oh, okay, yeah. Okay, so the tick marks have to match. We good with that?
Yeah. Go.
What's that? All right, so new concept for you guys. New concept. Let me pull this up. Bear with me 1 second. Mackenzie, how's it going over there?
It's good.
Can you see everything?
Yeah, I can see it all.
You picking up what I'm putting down?
Yeah, I actually got that one, so.
You actually got that one? Good.
Yeah.
Bye.
Danielle, good to see you.
You too. Bye, Daddy. Bye.
Don't act like you're really friends with her. I hear you talk about her all the time.
Be quiet, Mr. Ferraro. You're gonna get me in trouble.
I hate that Danielle. Oh boy, oh boy. All right, so we've done a lot of classification of triangles. I think you guys are pretty good on this, right? So let's look at another concept. Whoa, 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 whoa. Come on, man. Okay. Jordan, you ready for this one?
Yeah.
All right. The third angles theorem, all right? What it basically says is if we have two angles that match in two different triangles, then the third angle is also going to match. So, using the angle tick marks as the idea, right? If I've got this triangle here and this triangle here, and I tell you that this one has two tick marks and this has two tick marks, and this one has three angle tick marks, and this one has three angle tick marks, the third angle is also, these angles are also congruent to each other. So if this measured 50 degrees, then this one has to measure 50 because it's got two tick marks, okay? If this one measured 60 degrees, all right, this one would be 60. And that would be 50 and 60. So what would my third angle have to be? 110, 180 minus 110, 70. So the third angle here would be 70. That's corresponding parts. All right, corresponding parts. We'll do the same thing with sides. But you guys should be able to get that. If we've got two angles that are corresponding between two different triangles, the third is also going to be congruent. All right. Now let's go up a little bit further. So here, this is a really, really important idea. All right. Basically, what they are saying here, and I'll walk you through the logic. The center, this is the interior of a triangle. Everything outside is the exterior, all right? And then we have exterior measurements, and they're going to give you exterior measurements. So the way that that works is I've got a triangle right here, right? I've got my triangle, and I've got a straight line. I just extend that side forward, okay? If that's a straight line, and I told you this angle right here was 120 degrees, what would this angle be? I'll call it X. If that's 120, what would that angle be? Drake says 60. Does everybody agree with him? Julie agrees. Darlin agrees. Melissa, you agree? Right? Karen? Because a straight line, a straight angle is 180 degrees. Now let me ask you something. What are the measurements? Oh, so we now have figured out that 120, right, plus 60, okay, that gives me my straight line 180 degrees. So I got 180 degrees here, right? Now let me ask you this. A straight line measures 180 degrees. What do the angles in a triangle add up to? 180 degrees also, right? So 180 minus 60 is 120. What do you guys think the measurement of angle B, angle A, and angle B add up to? We already know this is 60, right? These two will also add up to 120, right? Angle A plus angle B equals 120, right? Because the remaining amount in that triangle is 180 minus 60, which we already know because I just showed you how to do that, right? So 120. So the theorem, okay, the exterior angle says that the measurement, in this case they use the measurement of angle 1 plus the measurement of angle 2 equals the exterior angle. All right, so the remote angles, all right, these angles right here, A and B, okay, let me do this in red. These angles right here in red, okay, these are what we call our remote angle because they're away from, this would be adjacent, they're away from our exterior angle. So these are the remote angles, all right, and this one right here, I'll put this in black, is the exterior angle. Exterior angle.
Remote is what? Yes or no?
Let me ask you this. When I say the word remote, like if I said I went to a remote destination, what would that mean to you? Far away? Out in the woods? It was a remote location in western St. Lucie County, right? It's far away. Away from the noise, away, right? So these are far away from that. Because this angle here is adjacent to it, right? It's right next to it, okay? So A and B are far away. So A plus B equals the exterior angle. The remote, the sum of A and B equal the exterior. So if I told you, hi Lindsay, if I told you that, if I told you that the measurement of angle A was 57, what would the measurement of angle B be? Go ahead and do that in your notebooks.
Is it 3?
Okay, so I'm going to interrupt class now. Remember, measurement of angle A plus B, or the remote angle R1 plus R2 equals the exterior angle. So if I told you that this was 57 and we know that this is 120, what would angle B
Can I
be?
answer it?
What's that?
Can I answer it?
Yes.
Is it 63?
She's killing it. You see that? Mackenzie, even homesick, is kicking all your butts, especially you, Alejandro. You didn't even come up with that, did you?
I didn't try.
Huh?
I didn't try.
Whoa. We have to try. Does that make sense?
No, I don't get it.
Oh. So, A plus B equals exterior, right? So, A plus B equals our exterior angle, right? So the value of A is 57. 57 plus the value of b, which we don't know, equals what? 120, right? Huh? So now, look, I'm going to subtract 57 from here. I subtract 57 from there. I subtract 57 from there. That cancels out. 120 minus 57. 63. ¿Sí o no? ¿Sí? 63.
Yeah, I got it.
63.
I did my math wrong. I knew what to do.
Okay. Now, let's ramp it up. We got about 5 minutes. Let's ramp up the complexity a little bit. Mackenzie, you get that? Oh, you got the right answer. Of course, you're probably sitting there with your mom or your dad, and they probably gave you the answer.
They're at work.
At least somebody's doing some work, because you're just hanging around in your pajamas. So that's the exterior angle theorem. You know, if you guys are like me, whenever I used to see like complicated ideas in math, like I'd read that and I'd be like, what the heck is that? But then when I actually see it, it's like, oh, that's self-evident. Oh, this is an example of, remember I ripped up the angles? This shows how they always add up to 180. I have to do that for my online class. I got to find a better way to do that. I need to have my, if I use Photoshop, I could have done that. All right, so can you guys see this, or you want me to redraw it? This angle right here. Mackenzie, can you see that? Mackenzie? She gave one answer. She's already at the beach. Unbelievable. Saracelli?
I'm not at the beach. I'm in bed.
How are you writing in bed? All right, so number 19. Have we done this yet?
No, I don't think so.
You think it's scary?
Yeah.
Come on. All right, so I'll redraw it for Mackenzie's sake. You guys start to work on it, Mackenzie. I'm going to redraw this. When you guys go lunch, maybe you can give me an answer.
Okay.
If I told you all the stupid things I've done. Okay, so we got. Mackenzie, you can say, oh, Mr. Ferraro, that is a very nice triangle, a very nice exterior
You
angle.
did amazing. I'm so proud.
Nobody likes a wise ass, Sally. X, Y, Z. All right. So these are my points and my equations here, right? So right here, let's change colors. We will make this fancy. 5x plus 2, 8x plus 4, and this angle right here, okay, there's got to be 15x minus 18. 15x minus 18. So, who can tell me by a show of hands, how I would set up my equation? What do you think, Julie? Julie, if I told you that this was A, and this was B, and this was my exterior angle, how would you set that up? Equals? How do you like me now? That's awesome right there. So, I can erase that. So, Julie said 5x plus 2 plus 8x plus 4, 8x plus 4 equals 15x minus 18. Jordy, does that make sense to you? You know what you did, right? So now we're just combining like terms and solving for x, right? So because we're up against time, I'll do that real quick. So we got 5x plus 8x, right? Which is going to give me 13x plus 16 equals 15x minus 18, right? Now, I'm going to move my 13x over there. All right, so that's going to give me 2x. And add 16 and 18. So 16 and 16 is 32 plus 2 is going to be 34. Did I do that math right? 18 plus 16. 34, right? Correct. You want me to actually do that stuff for you? What I just did there? Huh? Are you okay with 2x equaling 34? Yes. Yeah. What I did here, I combined it really quick. So I said plus 18 here, which cancels out. I need to plus 18 here, right? And here, I'm moving this over to here. So I'm going to say minus 13x there. That cancels out, minus 13x there, right? 18 and 16, which would be 34, right? 15x minus 13x is going to give me 2x. I divide by 2, and I've got x equals 17. So now I just plug that back in. Oh, and what did they say? We needed to find the measurement of x, y, z. Examine your zipper. Gotcha. So 15x, so it's 15 times 17. So 15 times 17, man, this doesn't seem right to me. 5x plus 2, 8x plus 4, 15x minus 18. 2 plus 4. Ah, here's what it is. I said 16, that's not 16. 4 plus 2
Oh, I
is...
thought it was 14.
Yeah, 4, okay. 4 plus 2 is 6. All right. And now let's refigure this. So I got 13x, so that becomes 2x on this side. And so that's going to be 24 because I'm going to add 18 to both sides, right? So 24. So now we've got x is equal to 12, and then I'm substitute that back in. So I've got 15 times 12 minus 18. So 15 times 12 minus 18, okay? So 15 times 12 is going to be 180, minus 18 is going to be 162, equals 162. And then I can double check these answers. So I got 12 times 5 is 60, plus 2 is 62. And 8 times 12 is 96, plus 4 is 100.
Hold that thought, Mr. Ferraro. We'll be back.
You get it?
I'm getting on. Hold that thought.
That is nice. That is good work. All this for Mackenzie Soroselli. Testing me.
Hi. How am
All
I
right.
testing you?
What's that?
How am I testing you?
Oh, because of, I mean, it's kind of fun to do, actually. You know, I have to find ways to be able to deliver content online. And I like to use OneNote, right? But being able to project is pretty cool.
Yeah. Thank you.
Good work. All right, we'll see you at around noon, all right?
Okay. Bye.